So we want to know if we can model this scatter plot with a linear function. Now, these points do not look like they're on a straight line to me, but we could model this by a linear function. We could somehow draw a straight line through those points and get an approximation. What I mean is, like, if you're given this input value, there's the actual output value. We'd be saying the output value is this. If you use this as the input value, there's the actual output value. We'd be saying it's this. All right, so we get an approximation. Now, it doesn't look like a very good one, but here's the question. Can the scatter plot be reliably modeled? Okay, I would say no, because we're going to get a lot of error in our approximation. So let's say no. The points do not look, these points here do not look like they lie on a straight line. Right, this looks more like a curve, right? Well, I missed it here, but it looks more quadratic than, or exponential than it does linear. Now, what about in 13? Compare 13 to 12. Look at these points here. These points look to me like they could lie on a straight line or really close to a straight line. And that's the question. Determine whether the scatter plot can be modeled by a linear function. What do you think? Reliably? I think so. I think these points lie really close to or exactly on a straight line. So I'm going to say yes. This is the problem on linear regression. What we're going to do is, from this table of data, we've got input values and output values. We're going to build an equation. So here's our situation. The chart to the right shows a county's annual egg production. Model the data in the chart with a linear function. Now, they're telling us already that the scatter plot here would look linear. So we want to fit a linear equation to this data. All right, so model the data in the chart with a linear function using the points. Okay, here's a point, and here's a point. Let x represent the year, where x will represent the year, where x equals 0 is back in 94, and x equals 1 represents 1995, and so on. Okay, so x equals 1 is 94, x equals 1 is the year after, 95, and so on. And let y represent the egg production. All right, so x is the year. Here's x equals 0, 1, 2, 3, 4, 5, 6, and then y is the egg production in billions. Now, they're already giving us 2 points that they say lie on the line. They're giving us this point right here. Now, that's the first point, 1994 and 52.7. But we're supposed to let 1994 be the year 0. So what I'm going to write here is this point here in the year 0, that's when we start back in 94, and 52.7, and then this point here. Now, this is 1998. That's 4 years later, right? 94 to 98 is 4 years. So this is going to be 4 years later. In year 4, the egg production was 61.3. Now, because they already gave us that these points are on the line, we don't need to use our calculator and go through the statistics and linear regression computations. So what we want to do is find the line of best fit. So I'm thinking right away, find the equation of a line. So I automatically think y equals mx plus b, and y minus y1 equals m times x minus x1. There's my 2 templates. And can I use this one right here? Well, this one, I need the slope, which I don't have, but I can get it, and I need the y-intercept. Now, I do have the y-intercept right here, right there, because the first component is 0. But since I don't have the slope, well, let's use this. We haven't done that for a while, so let's just use that one. So what's our formula for the slope? We have the slope is equal to second y minus first y over second x minus first x. Now, as I look at these points, this is the first x I see, that's the first y. This is the second x, that's the second y. So let's substitute these values into our formula here, and we will get that the slope is equal to, all right, second y minus first y. Second y, 61.3 minus the first y, 52.7. So we'll have 61.3 minus 52.7 over second x minus first x. Second x is 4, first x is 0. So 4 minus 0. So 61.3 minus 52.7 is 8.6. 4 minus 0 is a 4. And on your calculator, that will come out to be 2.15. So there's our slope. So we've got the slope and we've got the y-intercept, right? This point right here, that is all up at the top here. That right there is the b. So let's substitute. So substituting into y equals mx plus b, we will have y is equal to 2.15, our slope, x plus b, which is 52.17. All right, there's the equation of the line of best fit. This is what we call the regression line, or the line of best fit. Now we're going to make a prediction. So what we're going to do is predict the egg production in the year 2000. So what we need is this. In the year 2000, x equals what? Well, x is the number of years since 1994. So we'll have 2000 minus 1994. That looks like 6. All right, so x will be 6. So let's put 6 into our regression equation. So we will have y equals 2.15 times 6 plus 52.17. I got that y is equal to 65.07. So we don't want, this is not our answer, okay? Don't be writing that. The question is up here, right, all the way up here. Predict egg production in the year 2000. Well, y equals 65.7 is not the answer. It says make the prediction. So let's write a solution to this. Let's write an answer. So I'm going to write this. In the year 2000, we predict egg production will be 65.07 billion. And that's in eggs, right? 65.07 billion eggs. So this is, I think, how we should be writing our solution, our answer here. They're asking us a question, so we will answer the question. Data on the per capita consumption in gallons of bottled water in a country are given by this table, all right? So it says model the data with a linear function. Now, they're already telling us that if we were to draw the scatter plot for this, the scatter diagram for this data, these points would lie pretty much on a straight line. So they're telling us that already. So now we just want to get the model. And what we're looking for is this. We're looking for y equals mx plus b. Now what we've got here is that x is the number of years since 2009. So x equals 0 is 2009 because we're 0 years from 2009. X equals 1, we're 1 year away. 2010, x equals 2, 2 years away in 2011, and so on, up to 4 at 2013. Now the y's, these are the outputs. This is the per capita consumption of water in gallons. So back in 2009, per capita consumption was 27.6 gallons. Now because we're already told this is linear, I can write this. I'm up here in the very first, I'm going to write right up here. And I have this ordered pair. At year 0, we have 27.6. So I'm going to write this as the ordered pair 0 and 27.6. And then I could use any of these here, but I think I'll use the last one. I will use 4 and 31.9. Now these are the 2 points I'm going to use, and one of them, you notice, just happens to be the y-intercept, right back, because that first component is 0. So this is where it intercepts the y-axis. 31.9 minus 27.6 is 4.3. And how do I know that? I did it on my calculator over 4. And this ends up to be a slope of 1.0 0.075. And now I have the y-intercept, right? I have the y-intercept right here, up at the top right. So I'm just going to substitute these numbers in. So right into y equals mx plus b, I'm going to get y is equal to m, 1.075x plus b, which is 27.6. All right, now, there is our regression line. This is the regression line. And what are we supposed to do here also? It wants us to make a prediction. Predict the consumption of water, bottled water in 2021. All right, so in 2021, x is equal to what? Well, it looks like everything started back here in 2009. So 2021 minus 2009, that's 12. So I'm going to write x is 12. So let's put a 12 in for x, and we will get y is equal to 1.075 times 12 plus 27.6. I got that y is equal to 40.5. Okay, now, I'm not going to write my answer as 40.5 because remember, what's the question? It says, make a prediction. Well, the prediction is not y equals. Like, what do you predict? Well, I predict y equals something. You don't say the y equals. So let's write a sentence for this to answer the question. So we can say, we predict that in the year 2021, the consumption, per capita consumption of bottled water will be about 40.5 gallons. Now what we want to do is find the value of k so that the line containing these points, all right, there's k. So here's the points that we have. We have this point, -3 and k, which we want to find out, and this point, 4, 6, is parallel to the line, okay, we want parallel to the line containing these 2 points. 5, 5, and 1 and -4. All right, now we know parallel lines have the same slope. Let's get the slope of the line between these 2 points. So this slope is going to be y2 minus y1. If there's a formula, I always write that formula so I know where I'm going. I'm going to get y2, second y, minus first y. So -4 minus 5 over second x minus first x, 1 minus 5. So how about -9 over -4? So the slope is positive 9/4. Now I want the slope of this line here. Okay, I would like this slope to be 9/4, right? Because I want the lines to be parallel. So I need this slope to be 9/4. Now here's the slope formula. y2 minus y1 over x2 minus x1. This is, okay, so second y minus first y. So second y is 6, first y is k. So 6 minus k over second x minus first x. So this is going to be 4 minus -3. So how about 6 minus k over 4 plus 3 is 7. Now this is m, and m we want to be 9/4. All right, so I'm going to put the 9/4 down here. Okay, now can we solve this for k? Well, we've got an equation that involves fractions, so I'm going to clear the fraction. So here's my plan. I'm going to eliminate denominators. All right, so get the LCD. What is the smallest number that 4 and 7 divide into? Smallest number that they both divide into is 28. So here's the plan. Multiply both numbers by 20, both sides of this equation by 28. I'll do it right here. So I'm going to get 28 times 9 over 4 equals 28 times 6 minus k over 7. Now, 4 into 28 goes 7, and then I get 7 times 9, which is 63, equals 7 into 28 is 4, and then I get 4 times 6 minus k, so we'll get 63 equals, now multiply through, 24 minus 4k. Let's subtract that 24. So we are going to get 39 is equal to negative 4k. Divide, and we will get k is equal to 39 over negative 4, but I'm going to put the negative on the top, getting negative 39 over 4. All right, so there's my k. Now, just in case the answer has to be written as a decimal, you don't know because they didn't really tell us. I'll just go ahead and make this division. So it's going to be, k will be negative 9.75. That's what my calculator shows.